So as we are taking the ketones, there is possibility of having three pyridine moieties attaching with nitrogen. But at this moment, we cannot have a say because these are groups which are very closely connected. Because of the steric ketones, it could be possible that it can happen, and there's possibility it can't happen. Maybe I can just cross-check my references and get back to the next session. Okay. But there is a possibility because we are using 2 moles of that particular aryl protein.
Okay, ma'am.
Sometimes we also use certain agents to some amount is required to get your reaction in forward direction. Because if 1:1 is not working, then you introduce 1:1.2 equivalents or 1.5 equivalents, but we would rather make a stable product which is going to happen over there. Sometimes reaction does not go with 1:1 itself. It would come back to its original product. So for making the reaction to happen in a forward direction, there is a certain thing to say, like we can enhance the number of moves that we are using. So there could be possibility in this case if it's the product that information that I have on the one product is being found in this particular reaction, but I'll cross check this.
Okay, ma'am.
So that are reactions and the example that has been finished for this session. Now we can quickly take up the question and answers that has been given for this particular segment. Before starting that, if there is any doubt, please let me know. Otherwise, we can just start with the examples itself.
No, ma'am, no doubts up to now.
Okay. So just give it a try if you have understood it well. What would be the answers for these questions? So first question says still coupling involved. So out of all these reagents,
Organotin compounds.
sorry.
Organotin compounds.
Right, you're right. So it involves basically organometallic compounds. The option C is correct. Right here. So can you please tell like what is actually a still reaction?
Ma'am, that is also a CC cross coupling reaction.
Right. And if you introduce carbonyl group into that one, or if you start with an acid chloride in that one, what you expect your product would be what? Which category it belongs to?
Carbon monoxide is involved, ketone will be produced.
Right, right. I think you have understood the concepts well. So try the next question, which is main drawback or drawbacks of still reaction is and are. You will find out either one answer or there could be multiple correct answers also.
The main drawback is the toxicity of organotin compound.
Yeah, that is there. Is there anything else that you can think of? The option is absolutely correct. That in organotin compounds are having toxicity level. Besides that, there is a low polarity also. They don't have a high polarity to go into the charge function. So the low polarity also has a drawback. This is a drawback for these reactions, which sometimes prove as a less reactivity for these reactions too. Right?
Okay, ma'am.
So another question is the advantage or the advantages of using, again, we have a thin organelle over the traditional R4SN compounds in the still coupling reaction. So what do you think?
Maybe the reaction can be carried out in aqueous media.
Yeah, because now you can consider that when we were talking about low polarity, meaning if you have an alkyl group that is less polar in nature, if you just have a methyl or ethane, right? This way. And now if I consider CH3, CH2, CH, which one is expected to be more polar? Polar means having a charge separation, right? There is no charge separation here. Here it would form a charge separation of positive and negative. There is no charge separation here. So that creates no polarity. That's where when you are taking only R4SN, there is no polarity or very low polarity would be there. And if you replace your three R groups with on 3Cl. Polarity has been increased, which makes the reaction to work in aqueous medium. Because aqueous medium, that means you're having water. Water is nothing but H positive and OH minus. This creates a polarity. So this is first is that it can be carried out in aqueous medium. And increasing the polarity, it is something to do with reduced selectivity or functional tolerance, but the toxicity level actually decreases when it becomes a readily dissolvable in the aqueous medium. So it will no longer be insoluble, or it would no longer be forming the gaseous film. It would be having a low toxicity. Is that clear?
Yes, ma'am.
Just a second. Please try another question. Give me two. So yeah, I think so have you tried this one?
Yes, ma'am.
So I think that how it is going to increase the reactivity in what way. So this we have, I think, written in the notes also.
Alkaline has high when compared to
So in case of
alkyl.
still
Do you
reaction,
think one?
alkyl mm, uh, has less reactivity when compared to those. Firstly, you need to identify like what are the substrates that can be used in still reaction. So specifically, the maximum reactivity has been seen with the benzyl groups. If you take any of the examples, benzyl has been seen to give you maximum reactivity, and acetonyl group is having the lesser reactivity. So if benzyl is being used in first and third reaction, and the trend is totally reversed. So we can straight away go with the option A, that benzyl is having the highest reactivity for still reaction. Alkyl is not having much reactivity for this one. And in that case, acetonyl also. Okay.
Yes, ma'am.
Okay. So the question 5 says that predict the product of the reaction. So this is very straightforward when you have a R1X halide group and R2S and
Yes,
R3
ma'am.
been considered in presence of CO, what it would be forming. Let's just take
Or
it.
ketone will be formed.
Yeah,
So option B, R1, CO, R2.
right. So option B is correct. There is one way of making a ketone using a stick reaction. Or else if I introduce RCOCl, which is your acid product, and then again treating it with R2, SN, R3, something like that. Again, it would end up giving you the same product, and but this is not going to produce a CO anymore because already you have started with the acid chloride substrate. So depending on the substrate also, your product is going to be same, but you need to be careful like what reagents are being required. The question can be twisted in other ways also. Okay. All right. So
Okay,
moving
ma'am.
ahead with question number 6, what is the basic difference between the still and the supercritical coupling reaction?
No, ma'am. I'm not very sure with this question.
Picture this one. It would be better to make you understand. for the still reaction, right? Where we saw that it is working like having R2, SN, R3. So there is SN. Whereas in Suzuki reaction, we have boronic acids, RBOH4 coils, and there is R2X. And this R1 and R2 forms an XBOH2 is happening. So what do you think? Like now, what is the basic difference for these reactions? So here we use a base in presence of base on the work, and in still reaction also sometimes we use the bases. Do you remember now? So in the still reaction, the transmetallation step is different because if you see the option A, use of nucleophiles, actually use of nucleophiles is different for both the cases, where R2 center and R2 center of the Suzuki is its variety of substrates. Use of the transition metal catalyst, that is same in both the cases because in both the cases we use a palladium based catalyst. So this can't be a difference. Also, their application is the synthesis of cross coupling. So there also both reactions they give you a cross coupling product. So this is also not the right option. In still reaction, the basic difference for what we have is firstly the nucleophiles or the bases that they use, they are different for both the reaction. Secondly, the transmetallation step, as I was mentioning, in their coupling reaction, the mechanism you see, the transfer of this R2 group is happening to palladium. Okay. So, for example, you have a palladium, and here you have R1, you have X here, you have ligand and ligand. Now, at this step, I am introducing R2, SN, some R3 group. So this group is now going to come at this place, and this is going to be taken by your SR3 group, right? And here R2 is being formed. So this is basically your transmetallation step where the groups of two different metals which is being connected to each other, that has been changed. Similar process happens when it is being treated with a boronic acid, where it forms a XBOH2 base is there. And in that space also, it takes up the X from your system, like it would be having R2. It would give your R2 to the palladium and X would be taken up by the boron. So that's where we are saying that the transmetallation step in their cycle is different because in one case SN is involved and another case boron is involved. Also, there are nucleophiles, the bases that we use that are totally different when it is in terms of still and the Suzuki coupling. So whenever you appear in the examination, you better have a proper knowledge for all the coupling reactions because they can be merged and some similarities and some differences would appear and it would be a good as they are going to ask in the next question. What are the similarities between still and coupling reaction? So what do you think? What would be the answer? So first is their application in synthesis of diaryl compounds. The catalytic cycle involves palladium-1 and palladium-3 species, the use of C-nucleophile, the requirement of acidic reaction conditions. So do you think that these reactions involve acidic conditions or the basic conditions?
Basic condition, ma'am.
So the last option is anyway. We just talked about that use of different nucleophiles in both the reactions. So the use of same nucleophile can't be a similarity. Have you ever seen in any mechanism where we are having a palladium-1 and palladium-3, whether they are stable in palladium-0 2 plus 2 state or palladium-1 2 plus 3 state? We are starting with palladium-0 and 2.
From 0 to plus 2.
Yeah. So even this is also not right. So what we end up having an application in synthesis of diaryl group. This is an application because if you have one aryl group AR, another aryl group AR2, which can be formed in both the cases. Just their reagents would be different. In one reaction, it would be tin organelle. The other reaction, it would be a boronic acid. But their product would be similar. So the answer, the correct answer is your option A. Is this clear?
Okay, ma'am.
Moving ahead to our eighth question, which is the role of copper in Sonogashira reaction. So as we were looking into the Sonogashira reaction, this is also a coupling reaction, but basically it is having an alkyne group. This is majorly has been seen for the alkyne group, and what that copper plays what role in that one? Is it to generate an oxidative addition intermediate of the type of R copper X and to give a rise to an alkynyl copper species to facilitate the reductive elimination step or to introduce a J7? So basically, can you have just the elements from the Shila? Okay, here. So we have an R1X and we have an alkynyl. So it is very important that in Sonogashira, alkynyl substrates are the important one. And here copper iodide plays a very important role because what it does is it gives you a copper C triple bond Cr. And that really helps in giving you a final product. So that is where reaction says that the role of copper in Sonogashira reaction is to give an alkynyl copper species. So this is very, very important where it forms a copper positive C minus integral bond C R2, whatever the thing would be there. So this is your alkynyl copper species because this is important. Until unless this is being formed, it cannot undergo the transmetallation step. So this is very, very important. Reductive elimination, it has no role to play. There only palladium will play. Oh, is that fine?
Yes, ma'am.
Now try the another
No,
question.
alternative to Stephen's coupling, ma'am.
Yeah, that's a Castro topic. So this is straight away. And last question is also very straight away. Hydrocyanation, we just read and we saw the mechanism also. Out of all these metals, which is the metal which actually catalyzes this reaction?
Nickel, ma'am.
Right. So with that, our problem session is also over. If you have any question or doubt, you can just let me know. We still have 20 to 30 minutes to end of this session. Otherwise, if you are done, you can leave the session.
I have a doubt, ma'am.
Yeah.
Ma'am, once again. Ma'am, in the previous sessions, we have seen CP with the metal and COT. When the metal is vanadium or chromium, lithiation takes place at CP ring, and when the metals are either titanium or chromium, the lithiation takes place at
Type Q,
yes,
that
ma'am.
C7H7 species,
Yes, ma'am.
right?
C7H7 ring.
Yeah, but I
In
think
that,
in case of chromium, in both the spaces it goes, as I remember. Can you remind me like which session it was? If you have any.
ma'am, not in the last problem solving session, before that.
Okay. So what is your question basically?
Yes, ma'am. In both the cases, chromium, it can be either at CP ring or at the C7H7 ring.
Yeah,
In one of the question also, it was asked that when it is chromium, where the lithiation takes place, ma'am.
yeah. So in that particular case, it can depletion can happen in any position for chromium at least. So if you see at a metallation, if we have, because that is chromium's reactivity. So if you have in this particular center, if I'm correct, you have a CP group, like I said, and you have a C7H7 group here. And in presence of lithium, if you have M equals to vanadium or chromium, it is expected to have more reactivity on your CP group. And this is because of the different transition metals property that we are using. And when you are introducing your titanium and chromium again, it would end up having your reactivity at this position. So in chromium, both the ways it can happen.
Yes, ma'am. In assignment only, it was asked for chromium, ma'am.
Okay.
I don't know for which I've given. I've given for one, and the answer came as wrong. The another one is right. It came like that, ma'am.
Just this one or the first one? Like you are saying, like you clicked on this one and the answer was this one.
Just a minute, ma'am. I'll just check and tell you.
Yeah. I have this assignment where they've only asked the question regarding the titanium, I believe. It's not asked for chromium. So this was the first question I believe that they have asked for the titanium and where you expect your PR is going to attack. This was for week
Oh, just
17.
a minute, ma'am. Okay, ma'am. Uh, Actually, it was asked for chromium only, ma'am.
In my assignment, like what I have discussed, it was more than
Week 7 assignment, ma'am. Seventh question. I've answered for lithiation at the C7H7 ring. The answer is given as lithiation will take place at CP ring.
is there any other reagent that has been given in that one, or it's a simple example?
No, ma'am. Only Li, lithium.
So if the base is there, then there's a possibility of having a substitution at both the places that I know. But in absence of the base, chromium has been given the reactivity for both the species, CP as well as C7H7.
Yes, ma'am.
This is actually confusing. Okay, I'll note it down. I'll speak to the professor because both the answers should be correct in that sense. As no other conditions have been mentioned, so they should be given a correct option for that. I'll just speak to them and get back to you with the answer for that. Will
Okay,
that be
ma'am.
fine?
Ma'am, in that session, I've asked about NO, ma'am.
Yeah.
Nitrophyl, whether it's yes, ma'am. Can you clear that, ma'am?
For that linear and bend question.
Yes, ma'am.
Actually, in my assignments, we don't see those assignments that has been given to you. We give a different assignments that what you have seen. So that assignment I have not seen at all. But generally, in nickel case, if it is giving an oxidation, the question that we were discussing about the linear and bend. So
Yes, ma'am.
it was supposed to be a nickel zero, I believe, with a linear structure because it would be having a plus one with linear and minus one with bend one. Okay, I'll note it down and I'll straight away mail to the professor to clarify these question answers and get back to you in next session for sure. Because I didn't
Okay,
receive
ma'am.
any response to the assignments. Yeah.
Okay, ma'am.
Besides, there anything else you can help me with? But that the question that we
So
were
far,
discussing about the NU, that was I think this one only, right? This only we were discussing about like
yes, ma'am.
whether it would be a linear or plus one.
Yes, ma'am.
Yeah, I'll just speak to them.
Okay,
So far,
ma'am.
it would be having in if it is a linear one, it will give you a NO positive that you have to keep it in mind. And if it is a red one, then minus one. That is a thumb rule. You consider it minus one charge. So in that state, you can calculate its oxidation state. Okay.
Okay, ma'am.
Also for the students, I think there is a forum where you can upload your questions and there would be live sessions with the professor itself. There also you can post your questions directly. I don't remember
Okay, ma'am.
when would be the next live session. There you can upload your questions directly. Or in your NPTEL session itself, there will be a forum where you can type your questions and then you can upload it. And those who actually handle those questions, because we only take up the live sessions. And in that regard, if you upload your questions, that will be going directly to the professor. So that would be a really help. I'll post from my side, you post from your side as well.
Okay, ma'am. Yes,
Is there
ma'am. Thank
anything
you,
I
ma'am.
can help you with?
No, ma'am. It's okay, ma'am. Thank you, ma'am. I shall leave, ma'am.
Yeah, if there is no doubt, you can leave the session. Thank you for joining me.